I will go to on with the next speaker, which is Zhao, who is a professor at the University of Tongji, and also in FIB, he's a member of Commission 6 Prefabrication, and he's organizing also the symposium in Shanghai that is had a lot of changes lately, and he will tell us something about this too.
Hello, dear colleagues. My name is Zhao from Tongji University. As I also represent the local organizer of FIB Shanghai Symposium. So it's also, yes, really my duty to give a simple current situation report on the event. You know, we have moved the dates from the end of April to November 22 to 24 because of this novel coronavirus epidemic. Until last week, we still hoped the situation could recover normal. Perhaps, yeah, in the coming months, something. Then even part of you, could visit Shanghai and present the rescheduled symposium. Unfortunately, last week in Beijing, some new local coronavirus cases turned out. After more than 50 days, no local case in that area. And the administration found the new cases were connected to a seafood market. It's terrible and really a heartbreaking news for us. So last Friday, I had talk with our university coordinator who take charge our conference hosted by Tongji. He suggested us to change our symposium to an online conference. So the day before yesterday, I also discussed this issue with David and Mary. It seems the FIB Shanghai Symposium has to be online. We will keep close contact with FIB headquarters and the Secretary General David. Most possibly, the final formal decision will be issued in July through the symposium website and the group mails. The FIB media will also publish the message at the same time, I think. Thank you for support FIB Shanghai Symposium. So far, we have received 326 full papers. We are still waiting another 108 papers, as we only have the abstract at this time. The symposium will become online, as I just said, but we will have the same proceeding like other FIB annual symposium before. We will also send the papers to scopers. Online symposium means lots of new challenges. We will do our best and try to have a successful conference in this November. So once again, I thank you all for your support and look forward for your online presentation. So now I change to the second part of my presentation today. Topics on precast concrete structures, the evidence from laboratory work. Before this presentation, I'd like to thank David for inviting me to present this FIB webinar. I will try to answer 3 questions, for my presentation. First, why do we talk about precast concrete structure so often now? So the second one, precast make monolithic concrete structure. And the third, the behavior of the both connected precast concrete structure. So first, we need to talk about the precast concrete structure. You know, concrete, we can use it in precast or cast in situ. So concrete is really amazing. The big advantage of concrete is we can cast in place. So by one step, you can got your solid structure. Thinking about a car, you can't make a car in your own place. It must be made in the factories. So for precast, the structure members are cast in factory. You just need to move the members to side and put them together to make a structure. You need at least two more, even more steps. More steps mean more uncertain risks. So we need, I think, for precast, we need to think more. Precast is easier for quality control, but I like to mention here, the quality control perhaps related only the member, the member, the precast member. It's friendly to environmental. It's the most sustainable way of concrete usage. High values for us. Yeah, it's true. We need to consider use more precast technology. The picture here shows the history of the precast concrete structure in China. Yes, from 1950s. Let's just skip this slide. In fact, for casting in situ, you can use, you can also use some precast members. For example, the widely used hollow slab. When we talk about precast structure, generally we mean full or part of the structure are made of precast members with wet joint or dry joint. So then this quality of in-place work and the seismic capacity become the key issues of the structure system. So then comes our second question. Does precast make monolithic concrete structure? In this part, we will talk about if precast concrete structure with wet joint could have the same or similar seismic capacity. I mean, compare with the cast in situ structure. So let's take this concrete frame as an example. We choose the joint as the test model, as you can see. Totally, we have 4 models here. All of them are 4 scale. For the first one, it's cast in situ with beam, column, sub-assemblies. We call it sub-assemblies. The second one is precast concrete, beam, column, sub-assemblies. But the joint part, the wet joint, we use normal concrete. Then we have another 2 specimen. We call it precast concrete beam, column, sub-assembly with, wet joint using fiber reinforced concrete. So we can just keep going. Here you can see the details for this specimen. the cast in situ one, all the detail is shown here. Here you can also see the precast members. For the precast specimen, you also need the joint part. For the joint part, not only the precast, I have all the details for the shear reinforcement detail of the joint. The joint part. So for the first one, cast in situ, the distance between the stirrup for the joint is 60 millimeter. With stir ratio 0.83. For the second one, the wet joint used normal concrete. So we follow the same distance like the cast in situ one, the same ratio of the shear bars. For the third and the fourth specimen, we use the fiber reinforcement concrete. We increase the distance of the stirrup from 60 to 120 until 180. So the ratio of the steel bar decreased. But for concrete, we use the fiber reinforced concrete with 0.8 and 1.1 ratios of the ratios for the steel fiber. So the picture come and show you the cast in situ specimen and the precast one. So we can keep going. So here you can have close look for the joint. This one with more stirrup use the normal concrete. This one with bigger distance we use fiber reinforced concrete. This one we use more steel fiber. So that's the philosophy of the specimens. So for loading, we use the loading frame. Here you can see, for sure, the specimen. Then you can see the actuator, the reacting wall. We follow cyclic loading to see the seismic behavior of the specimen. So after the test, you can see the pictures. So the first photo show you the cast in situ specimen. So the front side and the back side. So you can see the hinge really occur at the beam end. For the wet joints, use normal concrete. We got almost the same damage model. This front and the back side. For the specimen, with joints using fiber reinforced concrete, we got almost the same, even better result for the joint part because we use the steel fiber. So that's if you go to the curves, because the loading and the force and the displacement curves. So you can see the curves for specimens are very, very close. Here you can see the skeleton curves for the all four specimens. It's it's very good. Matched. I think they have we can say for specimens really have the same seismic capacity. So we can also from the test data you can also calculate the damping ratio something to show the energy dissipation factors. So I think I just skip. For short conclusion, I like to say the precast concrete beam column joint has the same seismic behavior with the cast in situ joint. So the another conclusion is the shear stir-up can be decreased if the joint part cast by fiber reinforced concrete. For the second example, I'd like to take some wall panels. So for this test, there are totally 7 panels were tested. So you can say first you can see the detail for the connecting part of the panels. So here you can see 7 specimens, but the first specimen is cast in situ 1. So we only have 6 specimens are precast wall panel. So for more details for the cast in situ 1, you can see all the bars, the sides. I think the same. The wall panel have the same size. The difference for the precast wall panels is the joint. The joint beam. And we call it a joint beam here. So for the PCW7 and the PCW8, we have 2 specimens with joints at the same place. The difference for 7 and 8 is the head of the joint is different. So then we have a specimen number 9 and number 10. For number 9 and number 10, we put the joint part in almost the middle of the wall panel. We just try to test the behavior of the joints, the influence of the joint on the seismic behavior of the wall panel. So for specimen number 11 and number 12, we have 2 connections. So you can say, yes, the location 1 in the middle, 1 in the bottom of the wall. So the picture here show you how the people put the wall panel together. So here you can see the connection beam like this. They try to put the wall panel in right place. They cast the concrete. So as you can see, yes, they tried to have a good job. You can see they tried to have a good job. But as you can see, the picture here, the quality of the weight joints, didn't, look good. We checked the mechanical property of the material, the concrete material. So from this table, you can see the property of the concrete for the journal connecting beam. They have lower, a little bit lower property compared to the precast concrete wall panel members. Generally, we need at least 10% high material strength for the weight joint. So this is really a bad example. For the specimens, after we finished the test, we got the loops here. So I think all there are 6 pictures here. Represent the behavior of the precast wall panels. Yes, like this. So if you keep a close look at the skeleton cap, so you can see the line with square represents the cast in situ, cast in situ specimen. So from this picture, you can see cast in situ specimen presented better result. From this table, yeah, you can see more clear. So for the maximum force, yeah, let's just look at this maximum force. You can see for cast in situ, we got, we got 410 kilonewton. Unfortunately, for all 16 precast wall panels have lower yes, maximum force, especially for specimen number 11, they only got 270. So that's the tested data. So for, we don't like to very clean, very detailed for the test. So I just like to present you a general result from the test. For this part, I like to say strength of the precast concrete wall with the joint connecting beam is lower, than that of cast in situ wall panel, because the quality of the wet joint was not well controlled. So for this case, you may need to decrease the strength value of your design. Then let's have a brief look on the behavior of both connected precast concrete structure. We developed a modular structure, precast structure system, as we show the picture here. So we can, we set this room as a precast because it's a modular, it's a modular unit. Just like a small room from a flat or even from a hotel. So we call it precast unit. For precast, we need to put all the units together. First, let's say the horizontal connection. So for the unit here, they have one wall, but we divided the one wall into two parts. So one half wall attach it to this unit, another part attach it to the nearby unit. So we put them together, use some bolt connector. It's real bolt. I can show more detail later. So then for the vertical connection between the floors, we use the bolt. We use the bolt system. We use the bolt system. So here you can see the bar, the connector, and the bolt. So we try to use this technology to have the new modern precast structure system. We totally test 3 models. They are 5-story model. So we call it M5 or M5 P1, M5 P2. So for the first one, it's ordinary. Ordinary here means cast in situ. So it's normal shear wall structure model. So for P1, it's modular structure system, but fully assembled. It's fully followed the cast in situ procedure. Why do we have this model? We just we just like to check the system, how does the system works. So for another model, we call it P2. It's real modern structure system. It's precast and the joints and fully assembled with dry joint. But this system for P1, this model also has the dry joint. But for P2, the dry joints, is a real dry joint. We put everything follow the precast precast way. But for this one, we just have the idea. We just have the idea, but we cast the model. We use the connector. We use the bolt, but we cast it in one time. But the joint is still there. So what's the purpose is, yeah, we for the first two model, we need to compare the idea. We need to see if the idea works or not. Then we have another tool. Yeah, it's not another tool. Yeah, we have a precast P1 and P2. Then we can see the influence of the assembly process. I like to call it full precast way. And so for the design, model design, we choose the size 1 to 4. It's 0.25 scale. So I think, yeah, we can just go a little bit fast. So here you can see the size, yeah, of the models. The size for the model, for 4 models are the same, but they use this one shows the precast model like this. So I think I don't have enough time now. I need to go fast. So here you can see the general size and the reinforcement. For the connection, yeah, for the connection, we need to design the bolt. Yes, we follow the expressions here to have a safe connection. So this, this picture show you how we choose the vertical connection bars. So that means how many bolts we need for the wall panel. For the horizontal connection, yeah, we show like this. It's really a big number of bolts because we like to use the bolt to represent the tie bars. You know, for shear wall, so there are not tie bars yet. So it's very, very boring, yes, for the designs, the detail of the design. So we can go to see the pictures. That's how we made, the specimen. So first, for the precast in situ, it's just, we just go the normal way, then we got the model like this. So for the P1, we put the connection, before casting. But I think for the joint, still there. Even for the horizontal connection, the wall are separated. So for the real precast one, you can see the unit. Yeah, we put all the unit together. Yeah, use the bolts. We connect, yes, also the 2 walls. Yeah, we use the bolts. The measurement, I suggest we skip it. We select some input waves, the earthquake waves. We check the spectrum of the waves. So then we can, perform the test. So you can see the video. Yeah, the videos in here. You can see the behavior for precast one and the behavior for the cast in situ one. So look at the cracks. So after the test, you can try to find out and record all the cracks. So this is for the ordinary one, the cast in situ model. So you can see this one for precast for P1, it's model assessed. In the cast in situ way. So that's you can see there also there are some cracks. quite similar, I like to say. Yeah, if you check the cracks, I think you got similar. Yeah, you can see the similar crack. For the damage, yeah, for the damage, we had damage for our precast structure. You can see it's the damages come from the bolt. I think a big number of bolts, the screw snipped. It's because it's damage. The damage is caused by the snipping. Yeah, by the snipping. So the picture here shows the dynamic the mode. The first mode, the second mode, the first in both direction, and also the second and the third mode. I think for the cast in situ model, yeah, you can say it's I think it's similar to the numeric result. We can got it from the test result. For P1, for the specimen P1, we got the similar, the similar model here. Then for the P2, the real precast model, we also got the similar model shape. I think it's important to have a close look on the change, of the frequency. So for the cast in situ, before the test, we got frequency at 6.75 Hertz. But for the system, we used the model system, we got a little bit lower, frequency. But if we follow the real precast way, we got more, lower frequency. So it's the difference is minus 3.7% and minus 6.7 percent. So if you keep increase the input of the earthquake waves, so we can got the change of the steel, this structure's stiffness, because its stiffness degrade. So here, so if after the 0.04 G, so we got the decrease, the percent of decrease of stiffness. So from these numbers, you can see for cast in situ, model, we got bigger, decrease, minus 5.6. For P1, we got only minus 1%. But for full precast model, there's no decrease. If you go look to the bigger one, so it's the decrease percent become to minus 34%. It was because the damage of the bolt. So if you go back step, if you check 0.72 G, so you still can got the almost the same decrease of the stiffness. I mean the percentage. So it's really a lot of test results there. So I think I can just stop here. From the test, we can got acceleration responses for this cast in situ specimen, also for precast 1 and precast 2. So I don't go very detailed for the compare. So it's I just show you the pictures here. So the picture here shows the displacement responses. yeah, for 3 models. For general conclusion, I think for precast structure with wet joints, it's possible to make the structure have the same seismic behavior like the cast in situ structure. Only, yeah, if the quality of the wet joints is well controlled. Generally, we suggest you use higher strength material, keep close check, keep close look on the in-place work. For precast structure, with dry joints, it's really doesn't have to ask the same seismic behavior like the cast in situ structure. I think a little bit different, a little bit not deformation on the frequent earthquake and the not energy dissipation capacity on the real earthquake maybe just what we wanted. So sorry, yes, I think I have to finish my speech now. I thank you all for your attention.
Thank you so much, Zhao. Well, I will just say something about there is some good questions about the presentation. A lot of people saying that they liked a lot of that. I will try to answer some of the questions about the symposium in Shanghai. That somebody asked if it was free, because Jean-Michel said that the PhD symposium was free. In Shanghai, what we will do is to have a the reduced fees for online presentation. It will be, they are not finally decided, but they will be about half of the normal fees, something like that. So people can send a paper, present it online, and even the paper can be on in the proceedings. If this goes all the way, and these proceedings will be sent to Scopus as we do in a FIB conference. So I think this is one thing. Then there is another question to Zhao about from Hegadi about how precast construction is more sustainable than cast in situ concrete. I can answer this question a little bit because we finished a group on sustainability of precast structures just last year, and the FIB has published a bulletin on sustainability of precast structures, and it's a good place to see how to evaluate precast structures against other structures. You cannot say this in general, everything, but I can give you a couple hints. Like normally precast structures use more strength or higher strength concrete, and they use less materials, so this is a big advantage for the less use of materials, less use of energy. And in this way there are many other ways also that you can evaluate this, but this is, let's say, a general statement that can be evaluated in detail if you take a look at this Bulletin 88, sustainability of precast structures. And well, in many cases it is true, because you are trying in the precast industry to use less materials. I can see Zhao has come again.
Okay.
Can you hear me now?
Yes.
Okay, great, very good. So
yes, I can hear you now.
I can ask you a couple questions, Bin. That
okay. It's okay.
One is I already started to answer is how precast construction is more sustainable than cast in situ concrete. I talk about the Bulletin 88 and the use of materials. But maybe you want to add something else there.
Okay, I think you can answer this question much better than me. Okay.
Okay, so and then I have another question from Sunil Rayani, saying that is it possible to strengthen these precast connections? Can we use a stainless steel wire mesh for the same?
Yeah, I think yes. Yeah, you can try to go other way, just like your suggestion. We can use different way to for the connection. But I think the idea for us I don't know. The question is related to the certain experiment or the first one or the first test.
Yes. No, they're talking about. I understand they're talking about the second test.
The second one. The wall panel.
Yes.
Yeah. For the wall panels, yes, they can use different. There are some connection proved. Yeah. So for the test, so we just it's not me. The students just try to check the behavior of different ways. Okay. So I cannot tell the difference. So if even for this test, if the quality of the weight part is controlled, perhaps we can get better result. Mm-hmm. Okay. 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 We have another question here from, this is for the PhD, for the symposium in Shanghai. From Vyacheslav Yarmakovsky. He's saying, hello, Professor Zhao, thank you for your interesting report. And he's asking if it's possible to participate in an online conference in Shanghai with two presentations, one about high-strength lightweight aggregate concrete, and the second one about physical chemical basis of, well, I'm not going to read it. It's from the member of the expert council of the Russian Academy of Science. Yeah, it's, I think, for each participant, they can have two papers. Okay. They can have two papers. So it's no problem if we have two presentations. Okay, so thank you very much, Professor Zhao Bin. Thank you so much for this very interesting presentation. We will post it on live later on so people can take a look more slowly, because you had a lot of information, which is really, really interesting.